Hey everybody, it's Brad here and welcome to another Expanse tutorial. Today we're going to be talking about weather, and in particular we're going to be talking about how to extend the weather controller that we built in this video from like 2 months ago to be more complex, more fully featured, and ultimately to create more expressive, detailed, and realistic weather patterns. We're going to basically just do two things. We're going to add more cloud layers to the weather controller, and we're going to switch from using cloud coverage as a way of representing the cloud patterns that we want in different weather states to cloud presets that you can author on your own. What this is going to let you do is it's going to let you create the cloud presets that you want to get a really specific look, and then it's going to let you blend between them seamlessly while your game is running so that you can have vastly different cloudscapes whenever you want in your game with a low performance overhead. So with the scene set, no pun intended, let's get started. So here we are in Unity. I think I'm using version 2020. Let's just look. I'm using version, my project. What a great project title. It is my project. 2021.2.4 F1 here. Remember, Expanse is compatible with 2020.1.17 F1 or greater. And the scene I'm using is pretty simple. I've got a camera, I've got the Expanse Creative Sky, and I've got some terrain and a global volume with an exposure override set to be automatic. And finally, I have our weather controller that we programmed last tutorial. The way that it worked was that it had weather states that you define as scriptable objects that have three parameters. The fog visibility distance, it had the cloud coverage, which tells you how much the clouds cover the sky, and it had wind strength, which tells you how fast the clouds move across the sky. So I have three simple weather states here: cloudy, sparse, which with a lower cloud coverage, and stormy with a higher cloud coverage and bringing the fog in more. Then we have these weather states, and our weather controller basically just blends between them for a specified duration, then hangs out at its new weather state for a little while, and then starts blending toward another weather state. And it picks each of these states randomly. You can set how long the state transition takes, and you can set how long each state holds for. And you can here in the states array, populate the weather states that you actually want the weather controller to use. And just to demonstrate what this looks like, if I hit play, you'll see it's picking the stormy preset first, and it's transitioning to probably the cloudy one. Yeah, cloudy. Now it's going to transition through to sparse. And obviously these transitions are accelerated because, just it's easier to see them, right? I don't want to have to fast forward the video. So yeah, you can see this is pretty great, but it's also pretty bare bones. So our goal today is going to be to make it a little bit more feature complete and make it capable of expressing more like interesting cloudscapes and interesting weather scenarios. So how can we make this better? Well, if you look at clouds in real life, every day that you wake up and you look at the sky, the clouds look really different from each other, right? Sometimes they're big, puffy cumulus clouds. Sometimes they're thin, wispy cirrus clouds, or big, formless stratus clouds, and everywhere in between. And with a cloud system like this, which is what most actual AAA games today use, you really only get one kind of cloud, and you kind of have to pick a cloud style, right? Like what I have here, that's kind of a soft cumulus that looks good under all weather scenarios, and then you just change how much it covers the sky, and that's the limit of the different sorts of clouds that you can render in your game. The reason for this is that it is hard to blend between different cloud materials in real time, and Expanse uses a trick to amortize these updates over multiple frames to make it possible to blend between cloud materials in the context of a real-time application. Now, technical jargon aside, what does this actually allow us to do? It means that we can author a bunch of different cloud presets based on a bunch of different reference photos, one of dense cumulus clouds, one of formless stratus clouds, one of a big thunderstorm type situation, one of sort of the wispy clouds you would see over San Francisco. And we can smoothly blend between all of these in the context of our game. And we can use that smooth blending to create really interesting different weather scenarios that seamlessly transition between each other. So the way that you access interpolable clouds in Expanse is you're going to use a game object called the interpolable cloud volume. It's pretty easy to get this set up. Let's disable our procedural cloud volume. Let's right click, go to Expanse, Advanced, Interpolable Cloud Volume. And now if we actually want to interpolate presets, we can hit play. It'll work in edit mode too, but it looks better in play mode when you have it updating every frame. We can go to preset browser and we can just click different presets and it will blend between them. Right now it's functioning in something called auto mode, which just specifies a transition time. If I uncheck auto mode, then you'll see that the way that we actually specify the presets changes. We can just select between, we can actually use the base scriptable object. I'm gonna click sparse, and we can just drag between the two different presets. So yeah, that's the interpolable cloud volume. It's pretty powerful, it's pretty cool. It means you can interpolate between different cloud presets. There's one snag though that you should be aware of when using the interpolable cloud volume. And that is that you actually can't interpolate smoothly between two arbitrary presets. You'll see that if I try to interpolate between this preset antithesis and this preset brewing, the clouds change really suddenly at the beginning. And then they move a lot across the sky and get pretty blurry. The reason for this is that Expanse lets you specify unique tile factors for every noise type that is used. The problem with that is that it's hard to interpolate between noises when their tile factors don't line up. The solution to this is really easy. For any two presets, you need to make them compatible with each other. And the way that you do that is you can add the component preset mapper, cloud preset mapper. You can select a source preset, select antithesis optimized, and a target preset, the brewing preset. And I can map the source preset onto the target preset. So what this is gonna do is it's gonna make antithesis, the first preset, compatible with brewing, the second preset. Say map source on the target, and I will go to just weather here, and I will save this as antithesis mapping test. Great. Now you can see in the weather folder, I have this antithesis mapping test asset. And you can see that when I try to interpolate between brewing and antithesis mapping test, it pretty much just works now. It's still a little bit blurry because we're not using neighborhood clamping with reprojection, and that, when you transition really fast, is gonna blur it. If you turn neighborhood clamping on, the blurring will go away. Or if you don't wanna have neighborhood clamping on for some reason, then you can just transition slower. I mean, we're transitioning over 5 seconds here. You probably would be transitioning the clouds in way more gradual, like over 2 minutes, 3 minutes, that kind of thing. Okay, great. So now we understand how to use interpolable cloud presets with Expanse. We know how to use the cloud preset mapper to make sure that two presets are compatible with each other. But how do we actually work this into our weather controller? Well, every weather state is going to have a cloud preset that's associated with it, right? You know, we want to, instead of specifying the cloud coverage and just saying how many clouds are there, how much do they cover the sky, we want to actually use a cloud preset that we authored ourselves. And so the first thing that I'm going to do is I'm going to modify the weather state description. And so I'm going to go to weatherstate.cs here, and you can see we've got our 3 parameters: visibility distance, cloud coverage, and wind strength. I'm just going to replace cloud coverage, and instead of cloud coverage, I'm going to have a universal cloud layer, which is the name for Expanse's cloud presets. And I'm going to call this mCloud preset. I'm not going to give it a default value because it will just be none as a default, right? And then we'll have to select which preset we want when we create the scriptable object. And you'll see that if I now go back to Unity, it's going to get really upset at me because the weather controller says, wait, there's no cloud coverage in the weather state. So we got to go back into the weather controller. We got to search for cloud coverage, and we have to see that we're using it in this spot here where we take our clouds and we set the coverage based on interpolating between the current preset and the next preset. And we are going to delete this, and I'm going to write here to do interpolate between cloud presets. Question mark, because how do we do that? We don't know yet. But now we should see that it compiles fine. And we can see that if we go to our weather states, there's an empty slot for a universal cloud layer. Cool, so I'm gonna take a break and I'm gonna model a couple of different cloud presets to use with the weather controller, and I'm gonna put them through the preset mapper to make sure they're all compatible with each other. And then I'll come back and show you the different presets, and then I'll populate the weather states with them. Okay, so I have modeled 3 different cloud presets. This is the medium clouds preset. It's just based off of that antithesis preset. This is sparse mapped onto it. Sparse is just sparse. And this is stormy, which is very stormy. It's high coverage preset. And these are all mapped onto, both of these two are mapped onto the medium clouds preset, so they're all compatible with each other. I'm gonna, for the cloudy weather state, I'm going to use the medium preset. For sparse, I'm going to use sparse mapped. And for stormy, I'm going to use stormy mapped. I'm getting a drink of water. You know, something we started doing is we started using these jam jars as glasses. We broke a shit ton. We got these glasses from Crate and Barrel. They're highball glasses, so they're really, really thin. Let me go get one, actually. It's like this bullshit, right? It's like a 3 millimeters thick or something, and basically if you hit it with any kind of force on any item that's not also another 3 millimeter thick glass, it breaks. So we've broken 3 of these tall ones and 2 of these short ones, which means we are looking for alternative glass solutions. Do you guys drink tap water? Or do you filter? I think in San Francisco we have really good tap water. I know some people have a Brita filter here, but having the Brita filter is the most annoying thing. It's like, you know, you fill the thing up, right, when you're thirsty, but then you gotta wait for it to go through, and then you drink all of it, and then you don't fill it up again, and the next time you're thirsty, it's empty, and you gotta fill it up and wait again. The tub is smaller than the amount, than like the Brita filter itself. So you gotta fill it up, wait for it to drain, and then fill it up again, and it drains more into there because there's still space left down here. It's like, who's gonna do that? It takes so long for the thing to filter down. Okay, so let's take a look at how we actually use the interpolable cloud volume to transition between the presets we just authored. So let's open up our weather controller script. I'm gonna go to the top here where we have our cloud volume, and I'm gonna keep this around actually for, you'll see why in a minute. And I'm going to add a cloud layer interpolator. I'm going to call this mCloud interpolator. I'm going to comment this a little bit. Say clouds, fog, transition parameters. Cool. Now, down here in validate parameters, I'm gonna add a check to check if this is null, the interpolator. This way, if it is null and we try to use the weather controller, it doesn't do any of this other stuff, and it just says, you need to make sure it's non-null, and it prints that out for you. And then I'm gonna go down to interpolate parameters, and the reason I kept the other cloud volume around is because that's where we're actually going to set the wind strength. We're going to use that on the procedural cloud volume. So I'm going to keep these lines here where we set the wind strength. And I'm going to say, set the noise velocities on the cloud volume in accordance with the interpolated wind strength. And this to do interpolate between cloud presets, I'm going to change to just interpolate between cloud presets. And now I'm going to take the cloud interpolator and what am I actually going to do with it? We don't really know yet, actually, because we don't know anything about how the cloud layer interpolator works. By the way, if you guys use Visual Studio Code, I'm not like a big coder tool guy, but Visual Studio Code is an awesome code editor. And this is something you can do in lots of different code editors. But if you hit Control P, you can search for cloud layer interpolator, and the file just comes up and you click on it and go to it. So let's see what we have here. Let's see, for one, I see that there's this field auto mode that I talked about earlier. And it says whether the interpolator is functioning in auto mode, where interpolation amount is progressed with time, or auto mode where it is not. All right, I gotta change that documentation. Manual mode where it is not. So I wanna make sure that this is false, because I wanna use this value, clamped progress, to drive the interpolation amount, because we're gonna be the ones to say tell the interpolator how much to blend between the presets. Cool. So the first thing I'm gonna do is I'm gonna say mCloudInterpolator.mAutoMode equals false. You could imagine doing this one time in Start or something, but I'm just gonna do it here and interpolate parameters to be safe. The next thing I'm gonna do is I'm gonna make sure that bypass offset is true. I wanna make sure that the clouds always use the same offset no matter what preset they're using. That way, the wind strength and the clouds moving across the sky is consistent from preset to preset. So I'm gonna say cloudInterpolator.m bypass offset equals true. And now we can see our manual mode only parameters here. We have the current preset, the target preset, and the interpolation amount. It's really just as simple as saying mCloudInterpolator.mCurrent preset equals the current preset, mTarget preset equals target preset, and mInterpolation amount equals clamped progress, the amount to interpolate between the current and target preset. The way that we get the presets, remember, is we just index into our states array that has all of our different weather states at the current state index, and we call, what is it in the weather state, mCloud preset dot mCloud preset. We'll say mTarget state here. I'm going to delete these comments because they're pretty redundant, and make sure that this is a semicolon. Yeah, and there you go. Auto mode to false, bypass offset to true. Current preset is the preset taken from our current state. Target preset is the preset taken from our target state. And the amount to interpolate between them is our progress from the current state to the target state. And now, if we open Unity up and we did everything right, we won't get any compile errors. So now, let's take a look at our weather controller. If we enable it again, we'll see that we have this empty slot for the cloud layer interpolator. If we hit play, we'll see our nice little error printout functioning. So let's re-enable the interpolable cloud volume. And let's make sure here, I'm gonna delete this old procedural cloud volume I was using for authoring, and make sure that where it was in the slot in the weather controller, I'm going to use the actual procedural cloud volume that's underneath the interpolable cloud volume here, in this slot, to make sure I'm using the right one. So I'm going to delete this. Now you'll see this is missing, which is good, because we're going to drag over the interpolable cloud volume to the interpolator and the cloud volume underneath it to the clouds slot. And now, if we hit play, we should see this work. Great, so this is the stormy preset. And you can see that we are transitioning to the sparse preset. And now we are transitioning to the stormy preset again. So that's sick, that just worked completely. Oftentimes, there's more than just kind of one visible layer of clouds in the sky. We'll have like a second one, right? Like sort of a low down cloud layer that's got cumulus stratus clouds in it, and a higher cloud layer that's got high flying wispy cirrus clouds in it. So I am going to actually add a second cloud layer to our whole setup here. I'm going to add to my creative sky an interpolable cloud plane. You know what? I'm gonna do what I did last time. I'll make 3 presets, I'll map them to each other, and then I'll show them to you. Okay, cool. So I've made the 3 cloud plane presets. Let me show them to you. I have medium 2D, which is this. I have light 2D, which is that, but a little bit less dense with some different lighting parameters. And then I have storm cover 2D, which is way different. It's like just this kind of really gray, really like stormy looking kind of stratus cloud looking thing. So these are my 3 presets. And I'm now gonna modify my weather states to accept another preset for these clouds. So I'm gonna go to weather state, and I'm gonna just add another universal cloud layer, and I'm gonna call this M cloud plane, M cirrus preset. I like that, cirrus preset, that's cool. Now, if I go back in here, you'll see that my weather states now have a slot for a cirrus preset. I'm gonna type medium 2D, assign that to cloudy. For sparse, I will do light 2D. And for stormy, I'm gonna do storm cover 2D. Yeah, this one. Cool. Now I'm gonna go back over to my weather controller. I'm going to go to, for now, let's not do the wind speed business for the other one, because there's gonna be some other mapping that you might use for that. Instead of just using the same wind speed as you use for the other volume. I'm just gonna assume these cirrus clouds are static. They don't move across the sky. Really, actually, when you look at cirrus clouds in the sky, they're so high up that they oftentimes appear to not really move anyway. So I think that this is gonna be fine for our purposes in this video that's only going to be used as a tutorial. You could add that really easily if you wanted to, in the exact same way that we do for the other clouds, the volumetric ones. So I'm gonna say cirrus clouds. It's another cloud interpolator. I'm gonna call it M cirrus interpolator. And now I'm going to scroll down to where we validate. I'm gonna add this to the validation stack. That's a new phrase there, the validation stack. That makes this sound way more complicated than it is. It's literally just 4 null checks ORed together. And then I'm gonna go to interpolate parameters, and I'm going to say at the bottom, interpolate between cirrus presets. I'm just gonna copy all of those here. We could turn this into some kind of abstract function that interpolates, takes an interpolator and sets the interpolation stuff. Screw it, let's do it. Okay. Let's make a new function, void interpolate cloud presets. I'm going to take in a cloud layer interpolator, a universal cloud layer A, a universal cloud layer B, and a float interpolation. I'm gonna call the float X. That's the interpolation amount. ABX, by the way, is like a standard, these aren't just names that I'm coming up with. This is a standard designation for interpolation functions. A is the first one, B is the second target, and X is the amount to interpolate between them. I'm gonna say, and then I'm going to say, copy all of that in there. I'm gonna replace this with the interpolator that we actually are using here. I'm gonna say this is preset A, this is preset B, and the interpolation amount is X. And now I can just say interpolate cloud presets using the volume interpolator, cloud volume, the current preset, the target preset, and the clamped progress. And delete all of this. Nice. Yeah, you know, it's always good to sort of try, whenever you see an opportunity where you're copy pasting code, always just try to put it into a function, a utility like this, you know, and then it's just gonna make your life easier. And now I'm gonna come down to where I was gonna copy and paste stuff, and I'll use the same function, but instead I'll use all of the Cirrus stuff. So I'll use the Cirrus interpolator. Instead of mcloud preset, I'll use mcirrus preset, and still the clamped progress. Beautiful. So now let's see if this compiles. Wonderful. Let's take this procedural cloud plane that we used to have for authoring. Let's delete it. Let's go to the weather controller and make sure that the empty Cirrus interpolator slot is filled with our interpolable cloud plane. Check that to turn it on. And now, if we hit play, nice, we have Cirrus clouds. Beautiful, look at that. And now they're getting, yeah, well, you can't really see, but I think if we disabled the cloud volume here, you would see that this is mostly, yeah, this is like a swath of gray. And now it's going back to the sort of texture cloud representation. And we'll see where it goes next. Yeah, so now it's going, this is our like really dense sort of gray, stormy look here. Shit guys, I mean, that's it. That's the weather controller. I think something that's not quite apparent in this video that hasn't really been showcased is just how powerful this is in sort of changing between really different looking presets. So I'm gonna go ahead and I'm gonna author some more presets, and then I'm gonna just put up a video here of the weather controller that we just built, transitioning between like a bunch of different looking cloud presets. That was pretty cool. It actually was pretty cool, I think, because most AAA games can't do what we just did with Expanse in half an hour or 45 minutes. I think that this system is a big upgrade from the previous weather controller that we built. It lets you author presets that channel a particular mood or match a particular reference, and then load them right into your game and your weather system and just use them. I hope that this sort of system, it brings a new degree of realism or helps channel the sort of strong emotions that we have associated with different weather conditions and bring them into your game. Well, that just about does it for this tutorial. If you've got questions or your code's not working, I encourage you to come and drop by the Expanse Discord server. I'll throw a link to that in the description. It's a fun place to talk about clouds, Unity, games, digital experiences, programming, art. Really most topics are okay. So drop by and we'll help you out with your problems. Well, if they're simulated weather related. But anyway, for now, I'll say thanks for watching and I hope you have a great day.